Hello, good day everyone. So today we are going to discuss about simple arithmetic operation in 8051. Already we have discussed about how to program addition, subtraction, multiplication, division both in 8-bit and 16-bit. So as far as this video is concerned, we'll be discussing about other um, four programs related with sum of n numbers, largest of n numbers, finding out the largest of n numbers, and sorting the array of numbers in ascending order, and the last one will be like finding the factorial of n numbers. So let us start with the program for sum of n numbers. So as we have done in the previous cases, we'll have to click project, new Fusion project, and we'll have to select the P89V51RD2. I have done already those things, so I'm skipping those um, procedure, and I'm directly getting into the program that I have typed already. So this is the program for sum of n numbers, you can see. So here I assumed that I'll be fetching the data from the memory, and the first data from the memory will be the size of the array. I mean array in the sense how many numbers I want to sum up together. So that will be available in the first memory address, that is 4500, and subsequently the remaining numbers, I mean the elements that we want to sum up together will be putting in the subsequent memory addresses, that is 4501, 02, 03, 04 and 05. So that is the idea. So here what I've done is the first instruction mov dptr comma hash 4500, basically it initializes the dptr with this number. So this number will behave as a memory address when you are putting this at the rate symbol before the dptr register. So when I am writing movx, that is move external a comma at the rate dptr, so 4500 will be assumed as an address, and from where the number will be fetched into the accumulator. So this number first that is being fetched into the accumulator will be the size of the array, I mean for which we want to find the summation. Then I am moving the content of the accumulator into R0 register. Then I am incrementing the dptr to make the memory address point to the next make the dptr to point to the next memory address, so that the first data that I have given will be fetched into the accumulator next. So inc dptr, then again I am using this movx ca comma at the rate dptr, you can see. So whatever the number that I have fetched, I will be moving it into the B register. Now I am decrementing R0. So this decrement R0 is like, as I've already told you, the R0 will be the size of the array. So I am mentioning in this case like DEC R0, one of the elements has been fetched. So to represent that, I am decrementing R0 once. Then I am incrementing dptr. So my memory address moved to 4502 now. So here it becomes 4501. So here it will become 4502. The second value is fetched into the accumulator, and add a comma b adds the number a and b. So the result will be available in a. So I need to check whether a carry has happened. If carry has happened, I will be incrementing R1 register. So in case if carry is not there, then I will be jumping to MOV B comma A. So the content of the accumulator, I am transferring it into B register. So the first two numbers that has been summed up is available in B register. Then I am decrementing the R0 by 1. DJNZ means decrement and jump if no 0 R0. So R0 will be decremented once, and then it will be checked whether it has gone to 0. So here in this case, assume that we have given 5 values. So I'll take an example. So assume that these are the examples that we are going to feed. So 5 will be fetched into the R0. 5 will be fetched into the R0, and here in this DEZ R0, 5 will become 4, and when it comes to this dj and z r0, it becomes 3. So here it becomes 4 and here it becomes 3. So now the value is not going to 0, so again it goes to start. dj nz means if no 0, it comes to start again, and then it increments the dptr. So already you can see 45001 once, it has been incremented to 4501, then again it has incremented to 4502 in the previous case. Now it becomes 4503. So from 4503 the data will be fetched, and that data is added to the b. So b is already having the summed up value of the previous two numbers, that is added together, and then the accumulator content again is transferred to b. So now the summed up number is again transferred to the b register. Then now r0 becomes so 2. So initially once you can see in this DEC r0 becomes 4, then 3, now once done then 2. So it goes on until your r0 goes to 0. So your value will be, all the values that we have given, whatever we have given will be summed up to get the result. So 6 and FA initially it will be added, then FA and BC will be added, then BC and 2 will be added, and 2 and 3 will be added. And when 2 and 3 is added, your R0 will become 0. Okay, now let us run the program and check. So as we have given, the same values will give 5, 6, FA, BC. So here please understand, 5 is the size of the array. 5 is the size of the array, and 6, FA, BC, 2 and 3 are the numbers that we are going to sum up together. So 5, 6 FA, BC. Okay, now let us check. So first DPTR is loaded with 4500, you can see. Then accumulator is loaded with the 5. So the 5 has been fetched into the accumulator. Then the 5 is transferred into R0 register. So R0 happens to be now the size of the array, and MOVX A comma so INC DPTR, so 4501, your DPTR becomes 4501, so it points to the 6 now. So 6 will be fetched into the accumulator. So 6 is fetched into the accumulator, then accumulator content is transferred to B register. Then I am decrementing the R0 by 1, so it becomes 4 now. Then INC DPTR 4502, now FA will be fetched into the accumulator. So accumulator and B register is summed up together. Then checked whether carry is available, and in case if a carry is there, then INC R1. So carry is there, so R1 has been incremented by 1. Then the content of A is transferred to B, and DJ and Z. Now the R0 is decremented by 1, so it becomes 3. You can see R0 is decremented by 3, and it comes to the start again. Now 4502 is the DPTR's content, so it becomes 4503. So now it points to BC. Now BC is loaded into the accumulator, and it is added with the B register, and then jump if no carry to L. So it jumps, so it doesn't have a carry, so it jumps to the MOV B comma A. So the value of accumulator is moved into the B register. Then your R0 is reduced to 2 now, and DPTR is incremented by 1, so it points 4504. So the data 2 is fetched, and that is added with the um, accumulator, and again it is checked whether carry is available. So carry is not there, so R1 is not incremented again. Then R0 is decremented by 1, and then DPTR is incremented to 4505. So now the value 3 will be fetched to the accumulator, added with the B register, and J and C jump if no carry, so no carry, and the content of A is moved into B, and R0 is decremented by 1, so it becomes 0, you can see. So now it comes out of the loop, MOV A comma B. So the B content is moved into the accumulator, and I have mentioned the result in 4510. So that's the reason 4510 is initialized into the DPTR, and MOVX at the rate DPTR comma A, the content of A will be moved into 4510. So you can see C1 is the result, and then to move the carry I am incrementing the DPTR, and R1 value I am moving into the accumulator, and then that I am transferring it into the 4511. So 4511 has the carry, so our result is 1C1. So to check whether the result is correct or not, you can use the calculator. So 6 plus FA plus BC plus 2 plus 3. 1C1 is the result. That is the result that we have obtained. So this is the program for sum of n numbers. Next, let us discuss about the program to find largest of n numbers. So this is the program for largest of n numbers. Here you can see the same pattern I have used. Only thing is the basic algorithm will be I'll use the same numbers whatever we have used for the sum of n numbers. So here what we are supposed to do is, whatever the input that we have given, so 4500 will be having the size of the array, and then I'll be using one register named R1 register. I'll first check between the first two numbers, and get out the largest number of these two numbers. So then that number I'll use it for checking it with the subsequent numbers. So here you can see the blacked values, that is the dark shaded numbers are being compared, and FA is the result. FA is compared with BC, then FA is the result, and FA will be compared with 2, FA is the result, and FA is compared with 3, FA is the result. So here the FA is available over here, that's the reason it is appearing again and again. In case if a larger number appears in the last, subsequently the way in which the things will be performed will be different. Say here instead of 3, if you have FF, right, so in this case the result will be FA, and then again assume that these all the things will be FF. FF is larger than FA. So assume that this is the number that we are giving. So 6 and FA will be compared. So FA is the largest number, and FA and BC will be compared. FA is the largest. 2 and FA is compared. FA is the largest, and FA and FF is compared. Then FF is the largest. So after this comparison, R1 value will be changed. So R1 I will be keeping it as a temporary register, wherein the largest number, after the comparison between any two numbers, the largest number I will be maintaining it in the R1, register. So this is the algorithm that I'm going to follow. Let us check the program. So 4500 I am initializing in the DPTR. So first I am fetching the value into the accumulator from 4500, that happens to be the 5, that I am moving it into the R0 register. Then I am incrementing the DPTR to move to the next memory address, so 4501, and then I am fetching the first value into A, that I am moving into the B register. Then I am decrementing R0, so to mention that one value has been fetched, so I am decrementing the R0. R0 happens to be the size of the array. Then I am incrementing the DPTR, so you can see that it becomes 4502. So 4500, 4501 and 4502. So 4501 and 02 content will be compared. So the 4502 content is fetched into the accumulator subb a comma b. So I am using this subtract instruction to compare the values. So if accumulator has lesser value, obviously you will get a carry, you will get a borrow. So that is like a carry. Carry flag represents the borrow also. So a comma b, when I am making, it is like a minus b, a equal to a minus b. So we are not worried about the result, but we are worried about the flag. So when the carry flag is set, which means that accumulator content is lesser than the B register. B content in the sense that is the second register. So second register in the sense second memory address 4502's content. So here in this case 6 is fetched first, and that will be 6 is fetched first and that will be in B register, while FA is fetched next and that will be in A register. So okay, which means that A is the largest number. Subtract A comma B. If carry doesn't occur, then it means that A is the largest number, so the content of A has to be transferred to R1 register. So we are jumping to here and we are fetching the data, because like here the accumulator content is updated after subtraction, so we can't move that accumulator content. So what we are doing is we are fetching the data from the memory address again, and that is moved into R1 register. The same is updated into B register, because for the next checking, the B has to be having the subsequent number. So A will be fetching the next number from the memory address. So here DJNZ R0, so I'll be decrementing the R0 by 1 again, so it will reduce to so here in this case you can see here R0 will be, in this first case R0 will be first reduced to 204, because in this case 2 times we are fetching the data, so R0 is again reduced to 03. So here R0 will become 2 after this completion. After the completion of this one, R0 will become 2, and after this completion R0 will become 01, and after this completion R0 will become 0. So when it is becoming 0, it comes out of the loop. That's the reason you can see the DJNZ is available at the last. After completing the fetching process, DJNZ is available at the last. So during the first value fetching, DEC R0 will come into picture. Then after the second data has been fetched, DJNZ R0 will happen. So in this case when 6 is fetched, before that R0 will become 4, and after FA has been fetched, the R0 will become 3. So here in this case BC is fetched, so BC and FA is compared, so R0 is 2, then 2 and FA is compared, R0 is 1, and FA and FF is compared, so R0 after completing the comparison, R1 becomes FF. So this happens. So I mean B is loaded with the R1 register, then DJNZ R0 comma L2. So it comes to the increment DPTR. So it checks the next. If these two comparison is over, after these two comparison, the DPTR becomes 4503, and from 4503 the data is fetched into the accumulator, and that is again compared with B register, and this pattern goes on until your R0 becomes 0. So now let us check the program. So as we have given, we'll check the same value 05 6FA BC 2FF. Okay, now we'll check. So 4500 is loaded into the DPTR, and first the size of the array is fetched into 5, into the accumulator 5, that is fetched into the accumulator, that is moved into R0 register, and increment DPTR 4501 it becomes, and then the first value 6 is fetched into the accumulator, that is moved into B register, then decrement R0. Since I have fetched the first value, I am decrementing R0, then INC DPTR, so DPTR becomes 4502, and from 4502, that is FA is fetched into the accumulator, then I am subtracting that from B register, so I will not get a carry, so I am jumping into MOVX A comma @DPTR. So presently your DPTR is pointing 4502. So for 4502 points towards this FA. So the FA is moved into the accumulator, that is moved into R1 register. So R1 register I am having it as a largest number register, temporary register. So R1 content is moved to B register in turn again. Then DJNZ R0. So R0 is reduced to 3 and checked whether it has gone to 0. It has not gone to 0. So I am coming to the loop again. Then I am incrementing the DPTR. So DPTR becomes 4503. Now it points to this BC. So BC is fetched into the accumulator, and that is compared with FA. Obviously your BC and FA, BC is lesser than FA, so you will get a carry. So the content of B is transferred into R1, so that is FA again. So and then S jump L1, so the R1 content is again moved into B, so that is FA again, and then R0 I am reducing it by 1 and checking whether it has gone to 0. So it's not gone to 0. Then again I am fetching the next value from 4504, so that is 2. 2 is compared with the FA, again you will get a carry. Then B content FA is moved into the R1 register, then I am jumping, then R1 content I am reinitializing into the B register, that is FA, then DJNZ R0. So R0 becomes 1, then increment DPTR. So my pointer points to 4505. 4505 has FF and FA is compared, so you will not get a carry because accumulator content is larger. So it comes to fetching the FF into the accumulator, and accumulator content is transferred to R1 register, and then DJNZ R0. So R0 becomes 0, so it comes out of the loop, and R1 content is loaded into the accumulator, and I'm incrementing the DPTR. So it moves to 4506. In this case I am not reinitializing anything, just incrementing the DPTR and placing the largest number over here in 4506. So you can see in 4506 FF has been specified as the largest number. This is the program for finding the largest of n numbers using 8051 microcontroller. Okay, now let us do with sorting in ascending order. And one more thing, so here in this case, if you replace this JNC with the JC, this program will become smallest of n numbers. So same thing we can do. JC is like jump if carry, JNC is jump if no carry. The reverse of whatever the previous thing happened, that will happen for this case. So in this case, so initially 6 and FA will be compared, and 6 will be taken instead of FA. 6 will be taken to R1, then 6 and BC will be compared. So obviously 6 will be remaining, and 6 and 2 will be compared. 2 will be replaced into R1, then 2 and FF will be compared, 2 will be remaining. So that will become a smallest of n number program. So let us check that one too. So I am just changing JNC to JC, translate, build and rebuild. So same numbers will give 0, 5, 0, 6, FABC to FF. So now we'll check. 4500 is initialized into data pointer, 5 is fetched into the accumulator, so that is transferred to R0, that is the size of the array, INC DPTR 4501. So 4501, 6 is fetched into the accumulator, and the accumulator content is moved into the B register, then decrement R0. So the now we are going to fetch the we have already fetched the first value, so the R0 is decremented by 1, then INC DPTR, DPTR is moved into 4502. Now FA is fetched into the accumulator, so FA and 6 is being compared. So so in this case 6 has to be moved into the register, R1 register. So obviously you will not get a carry, so the content of B, that happens to be the 6, is moved into the R1 register. So and then I am jumping to MOV B comma R1, R1 content is moved into B, DJNZ R0, R0 4, it goes to 3, then again I am fetching the next value from 4503, so that is BC, and now BC and 6 will be compared. So in this case also 6 remains, so 6 remains in the B, so I am the process repeats, DJNZ 2, so again now in this case 4504, so that is 2 is fetched. Now JC carry will happen, so it jumps to the MOVX CA comma DPTR. So 2 is fetched into the accumulator, and that is moved into R1 register, and that is updated into the B register, then DJNZ R0. So R0, so now 4505 FF is fetched, so FF is larger than 2, so it reinitializes the B content into R1. So that is the end of the loop. So R0 becomes 0, that comes out of the loop, and then R1 content, that is 2, is moved into accumulator, and that is being presented as a result in 4506. This is the program for smallest of n numbers. So just change the statement of JNC to JC, then it becomes the smallest of n numbers. Okay, now let us move to the sorting. Okay, so whatever the logic or the algorithm that we have used in the previous case, the same thing we'll be using as far as this ascending order sorting is concerned, but only the changes will be having totally 4 iterations. So these are the numbers. You can check. So in case this is the algorithm, basic algorithm that we are going to do. So this is the size of the number, size of the array, and these are the numbers. So when these are the numbers that has been given, first these two numbers will be fetched and compared. So I mean, since 6 and FA, 6 is smaller and FA is larger, so it remains as such. So I mean, interchanging doesn't happen. While in case FA and BC, BC is smaller than FA, so BC is interchanged with FA in the second check, and in the third check, FA and 2 is compared, so 2 and FA is interchanged, and FA and 3 is compared in the fourth check, so 3 and FA is interchanged. So this is the iteration 1. In iteration 2, again from the beginning it starts, and whatever the fourth check that has happened in the first iteration is taken as the input over here. So in which 6 and BC again it is compared, so it doesn't have to change. Then BC and 2 is compared, so 2 and BC is interchanged, and BC and 3 is compared in the third check, so 3 and BC is interchanged, and BC and FA is compared, it doesn't have to change, so it remains as such. So now in the third iteration, again in this case the fourth check of the iteration 2 is carried over to the input for the iteration 3. So 6 and 2 is compared in the first check, so 2 and 6 is interchanged. Then 6 and 3 is compared, so both are interchanged again, and 6 and BC it doesn't have to change, and BC and FA it doesn't have to change. So in the iteration 3, almost the values are arranged in the ascending order: 2, 3, 6, BC and FA. So this fourth iteration is checked, is done, so that in case in some other numbers, if some of the numbers are being arranged in a different fashion, then it will be checked and it will be coming to the it will be arranging it in the ascending order. So as far as this particular numbers that we have given as input, only 3 iteration is necessary. Fourth iteration is for extra checking. Let us get into the program. So as we have done in the previous case, 4500 is initialized into the DPTR. So the content of 4500 is moved into A, so that happens to be the size of the array, and that is stored into R1 register. So this is the outside the loops. So this doesn't this happens only once. Then inside the loop I am having it with the 4500, because as we have seen in the algorithm, I'll have to, once I have given the input, I'll have to check till the end and then come to the beginning again. So this has to repeat 4 times. So for that reason I am fetching the 4500 again over here, so that it starts from the beginning again. So 4500 is fetched, and the content of A is placed into R0. So R1 is for the outer loop, and R0 is for the inner loop. So both are the size of the array. So I am incrementing the DPTR. So now I am fetching the first value into the accumulator. So first value happens to be, in this case, 6. 6 is fetched into the accumulator, and that is moved into the B register. Then I am incrementing the DPTR. I am fetching the second value. Second value is FA. FA is fetched into the accumulator, and then so first is available in B and second is available in A. So both are compared. A and B is compared. So if you get a carry, so then it gets into the operation of interchanging. So as far as this particular numbers are concerned, 6 and FA, you don't get a carry, because FA is in the accumulator, because the second number is in the accumulator. So obviously you will not get a carry, so you'll jump if no carry, it will comes to the L3. In case if carry has happened, then the interchanging happens. So let us come to the that one later. So I mean in the first case, since it jumps to the L3, it decrements the DPL in the sense data pointer lower. I mean basically this DPL has to happen in such a way like when increment is happening, when the operation is happening, what will happen is inside the loop it will again go for incrementing the DPTR. So instead of coming to the because like when this comparison is over, so my data pointer has to come here, but in the loop it will try to go to 4503 and 4504, but I need to compare 4502 and 4503. So that's the reason I am using this DPL over here. DPL is a DEC DPL is a data pointer lower byte. DPTR has two bytes. One is DPH, that is data pointer higher byte, and DPL, that is data pointer lower byte. So I am using DEC DPL. Then DJNZ R0 L2. So again I will come here and I will increment the DPTR increment the DPTR by 1. So obviously, as I have already mentioned, so it comes to 4502 now, and from 4502 FA will be fetched and BZ will be fetched. So FA is fetched into the accumulator, that is moved into B register, then increment DPTR. So BZ is fetched into the accumulator. So BZ minus FA will happen, so you'll get a carry. So it comes into the process of interchanging. So here MOVX A comma direct DPTR. At present the memory address will be 4503. 4503 will be the memory address, and in 4503 BZ is the content. So 4503 BC is the content. BC is moved into A, and from A it is moved into R2 register. So R2 happens to be the temporary register, and the content of B is moved into accumulator. So the B is having what? The B will be having the FA. So the FA is moved into 4503. Automatically you can see 4503 will be the content of DPTR. So we don't have to change the content of DPTR. Directly we can get the content from the B register, that I will transfer it into the DPTR. So likewise your FA goes to 4503, and after that we need to decrement the data pointer so that the BZ comes to 4502. So that's the reason DEC DPL has been happened, and R2 content is transferred to the accumulator. So R2 already has the R2 is the temporary register which has this BC, so that is moved into the accumulator. Sorry, that is moved into the 4502. So after it has after this process is over, then what I'll do is I'll jump to the L. So since here once I have decremented the DPL here itself, so I am directly going to the next process of incrementing the DPTR. So now FA and 2 is compared. So obviously in this case also FA and 2, when it is compared, you will get a carry. So in this same process of using the R2 as temporary register, the values will be swapped again, 2 and FA, and 3 also the same thing will happen. So after this process is first iteration is over, so what will happen is R0 will go to 0, then R1 will be decremented by 1, and it goes to L1, loop 1, and it reinitializes the DPTR to 4500, so that my memory pointer comes back to this one again in the iteration 2. So because in iteration 2 my data pointer should start with 4500 again. So that will happen with this L1. So again it will be reinitialized. The size of the array is moved into r0, and r0 content is reduced by 1. Then the first value is fetched, and that is moved to b, and the second value is fetched, and that is subtracted, and it is compared. So the routine process will go again and again till my r0 goes to 0. Again, when r0 goes to 0, again the r1 will be reduced by 1, and then it goes to reinitializing the 4500 for the iteration 3 and iteration 4 subsequently. This is the process that happens. Let us check with the program simulation. Translate, build and rebuild. So 0 5 0 6 FA BC 02 03 02 03. Now let us run the program. So 4500 is loaded in DPTR, and 5 is fetched into the accumulator, that is moved to R1 register, that is the outside of the loop. Then 4500 is reinitialized. Then the content 5 is fetched into accumulator, that is moved into R0 register, that is the inner loop content. Then inc dptr 4501. So here first we are reducing the content of r0 by 1. Then movx a comma at the rate dptr, the first value 6 is being fetched into the accumulator. Then A's content is moved into B. Then inc dptr, so it becomes 4502. So FA, now it will be fetched. So 6 and FA, it is compared. So FA minus 6, so you will not get a carry, so you will be jumping to the DEC DPL. So 4501 it becomes the data pointer, and then I am incrementing the data pointer again to 4502, and the content of the 4502, that is FA, is moved into the accumulator again, and that is moved into the B register. Then DPTR is incremented by 1. Now BC is fetched, so it is compared by subtracting. So now you will get a carry, so it moves into the process of swapping. So now DPTR is having 4503, so 4503 is having BC, so BC is moved into the accumulator. Accumulator content is moved to the temporary register R2, and the content of B is FA, that is moved into A, and that is moved into the 4503. So FA is moved into 4503, and DPL, data pointer, lower byte is decremented by 1, so it becomes 4502, and R2 content, that happens to be BC, is moved. The R2 is the temporary register content is moved into the accumulator, and that is moved into 4502. So after this is over, I am jumping to DJNZ R0. So R0 is decremented by 1, and then DPTR is incremented by 1, so it becomes 4503. So now FA and 02 will be compared. Again it goes for realigning in the same fashion as I have explained. So you can see FA and 02 is being interchanged. Then in the same way 3 and FA will be interchanged. You can see 3 and FA has been interchanged. So now the first iteration is over, so it has come to the outside of the loop. L2 is the inside loop, and the L1 is the outside loop. So now first iteration is over, so second iteration is starting again. So you can see again R1 has become 4, and R0 has become, it has been fetched with 5, and then it has been decremented to 4. Then from the beginning it goes for checking 6 and BC. 6 and BC is compared, so it doesn't change. Then BC and 2 is compared, so it will be interchanged. It gets into the process of interchanging. Then BC and 3 is compared, and value is interchanged. So almost only 6 has to come to the last. So in this case the second iteration is over. Now it comes to the third iteration. Now again 6 and 2 is compared, so it will be interchanged, and 6 and 3 is compared, that is also interchanged, and so that is the end of the third iteration. Now in the fourth iteration again the same process is repeated. So already our values has been sorted in ascending order. So now it's the end of the program. So 5 2 3 2 3 6 BC FA is the ascending ordered sorted program. So in case if you want to change it to descending order, then instead of J and C you just put JC, and let us check how the program runs. Zero 5 0 6 F A B C zero 2 0 3. Five is fetched, then fetched into R1 and R0, then 6 and FA is compared. So in this case obviously the interchanging has to happen, so it gets into the interchanging process. You can see 6 and FA is interchanged, and then 6 and BC will be compared, so that also is interchanged, and 6 and 2 will be compared, so it won't change, and 2 and 3 compared, and it has changed. So in this case in the first iteration itself the descending order has happened, FA BC 6 3 and 2, and after that the remaining iteration let it go, but it's not required. It depends on the number that we are giving as an input. So some numbers, some sequence of numbers will be easier for sorting, some numbers will take some time for getting it sorted. So here all the iterations are completed. Now it is completed. That's it. This is the program for sorting. Either it might be ascending order or descending order. Next is, let us check with the program for finding out the factorial of n numbers. So this is the program for factorial of n numbers. Here again I am fetching the data from the memory address. So here main thing is, as far as this program is concerned, the maximum number that I can give is 5, not more than that. So the program is designed for up to 5 only. So the data I am fetching from 4500 into A, that I am moving it into R0 register. The same value I am moving it into B register also. So and I am decrementing the R0 and I am checking whether it has gone to 0, because factorial is, if I am giving 5, it is like 5 into 4 into 3 into 2 into 1. not 2 into 1 into 0. So 0 should not be there. So that's the reason I have kept this djnz first itself. So I am decrementing the r0, and if it is resulting in 0, then I'll be jumping to djnz r0. If it is a not 0, then I'll jump to L, otherwise I'll jump to L1. L1 happens to give out the result, but in case if it is no 0, then I'll move the content of R0 to A and multiply A and B, and move the content of A to B. So and then S jump L3, and it goes over here. Again it decrements the value of R0. So R0 value is decremented by 1. Then again it checks whether it has gone to 0. If it has not gone to 0, then I'll move the content of R0 to A, then multiply again and transfer the content to B. So this is the factorial providing loop, and this is the conditional statement to check whether R0 goes to 0. So if it goes to 0, it will come out of the loop and it will print the result. So incrementing the dptr, so 4501 will be having the result. The content of A is moved into that one, and mov A comma B. Obviously in case if your number is 16-bit, the result B will be stored into the accumulator, and that is stored into 4502. So now let us check the program. So here in this case 4500, I'll give 5. So now 5 is fetched into the accumulator, that is moved into R0 register. So it is decremented by once, so it becomes 4, and then it has been checked whether it has gone to 0. If it has not gone to 0, then I am moving the content of R0 to A and then multiplying A and B. 5 and 4 is multiplied, then A content is moved to B, then I am decrementing the R0. So R0 becomes 3. 3 is multiplied by already the product that has been placed inside the B register. Then it is 3C, that is moved to B again. Then again djnz R0. So 2 is multiplied to the product. So it's 78. 78 is moved into B register. Then R0 is decremented by 1. So multiply AB again. So it's a 78 result. So djnz. So now R0 has gone to 0. So I'll come out of the loop and I'll print the value 78 and 78 and 0. It is supposed to be 0. Yes, so this one is wrong, so we'll remove this. So this is not required as it doesn't have any carry involved, so we'll remove this one. So we'll end up with movx @dptr comma a only. That is enough. So if it is 5, then 5 4 3 2 1. So 78 is presented as the result. To check it, you can always use the calculator. 5 into 4 into 3 into 2 into 1. 78 is the result. So this is the way in which you can program the 8051 microcontroller to print the factorial of n numbers. Thank you.